Welcome all of you. In the last class, we discussed a lot about the coherent transfer pathway selection. First of all, we discussed what is a coherent order, how a initial 90 degree pulse, which brings the magnetization from thermal equilibrium to xy plane, it creates, I said it creates coherent orders plus 1 or plus 1 and minus 1. And the magnetization in the xy plane, any pulse if you applied on that will create higher quantum coherent orders. That is what we discussed. And also I said we can choose a particular pathway for this coherence. For example, if in the one pulse experiment, an 90 degree pulse for the magnetization which along z axis brings it to xy plane, we have plus 1 and minus 1. I can choose only minus 1 coherent order. We discussed that, how to do that. And then this depends upon your pulse phase and the receiver phase. It is very important. Depending upon what your pulse phase, if you want to choose a particular coherent pathway, you have to choose the receiver phase accordingly. But then the question is, how do you know what is the receiver phase? For that I gave you an expression. The receiver phase is minus of delta p into phi. Delta p is the change in the coherence pathway from initial state to final state. You find out what is the initial state P, that is P1, and the final state is P2, and difference between these two is delta P. And if you know what is delta P, then you can select a particular coherence pathway. For that you can find out what is the receiver phase once you know what are your pulse phases. That we took the example of a simple one pulse experiment and showed how we can select minus 1 pathway. And we saw that receiver phase and pulse phase were exactly identical for that. If it was different, we also saw signal get nullified. That was not a right choice. So we can use the right phase cycling to select the right coherence pathway. We chose for minus 1 in a one pulse experiment. You may ask me a question, what about plus 1? How do I choose plus 1? Same way, we can do that. Now if I want to select the plus 1, now 0 and this is plus 1 and this is minus 1 state. Now 0 to plus 1 I said, initial state is 0 and P2 is 1 plus 1. Now delta P is, what is my delta P? P2 minus P1, it is plus 1. So the receiver phase, if you put it minus into plus 1 into 5, so it is minus 5. So the receiver phase is opposite to the pulse phase. If I have to choose plus 1 coherence pathway, then the receiver phase has to be opposite to the pulse phase. Very important thing, you should remember. So now if my receiver is here, if pulse is here, the receiver has to be opposite. Then only you can select plus 1. But earlier for minus 1, receiver and pulse phase both were going together simultaneously. Receiver was here, pulse was here. Here when I change the pulse phase here, receiver also I changed here. Like that I was doing for minus 1. Coherence pathway selection minus 1. For coherence pathway selection of plus 1, they have to be opposite. So let us say I choose for the first time 0x, then this is also 0x. In principle, it should go back and come, it should be completely opposite. We will see more about it later. If it is 90 x, then it has to be 270. If it is 180, it has to be minus 180. I am just taking the opposite phases. If it is 270, this is 90. What is 0, 90, 180? No, we have already discussed. What is the pulse phase 0, what is 90, what is 180, what is 270. So then the receiver phases has to be exactly opposite. Now if I do this, will I select plus 1 or minus 1? Let us see now. This is the situation. This is the receiver here, pulse is here, receiver is here. Now pulse is here, receiver is here, they are in the opposite phase. Here pulse is here, receiver is here. I am sorry, pulse and receiver both are here. Here receiver is here, pulse is here. Now what is going to happen? Signals 1 and 3 and signal 2 and 4 will cancel out and you do not see any signal at all. So if you use this one, we can nullify this one. We will completely eliminate the signal if we take opposite. So delta P, in the delta P case, what is going to happen is we can see if I want to take look for the delta P is equal to one coherent order, then we calculate the receiver phase is just exactly opposite to that. Then we saw that in this case signal 1 and 3 and 2 and 4 will cancel out and no signal will be detected depending upon the pulse phases. If the signal is detected in the other channel Y, the same behavior is expected. That is another important point you should remember. Now usually the phases 0, 90, 180 and 270 are written as 0, 1, 2 and 3. That is what it is going to be chosen. That is the way the instrument, the spectrometer, the vendors are writing. If I say pulse phase is 0, it is as good as telling 0 degree. If I say pulse phase is 1, it is 90 degree. If pulse phase is 2, it is 180. If it is 3, it is 270. Similarly, the receiver phase is 0, 1, 2, 3. Now the receiver phase, if it is X detection is this, what is the, if I detect on the Y axis, what will happen? That is other channel. Two channels are there, If I can detect along X axis or I can detect along Y axis, if I detect Y signal, then exactly they are out of phase for 90 degree. Then this will become 1, this will become 2, this is 3 and 0. They just undergo phase difference of 90 degrees. So when there are more pulses, multiple quantums are also excited and the coherence of P greater than 1 are also generated. To select the right coherence, we need to increase the number of steps per cycle to reduce the phase increments. That is very important point. When there are more pulses, multiple quantum transitions are excited. And of course, signal should be already on the XY plane, magnetization already in the XY plane. And you apply another pulse, then you create higher quantum coherences. So selection of a particular pathway, for example, how do I do? I will take an example, delta P is equal to -3. I want to see how I can choose this one. Like we can choose a particular thing, -1 we showed. We can also choose delta P equal to -3. How do we do for that? This is a situation we come across like this. Apply a 90 degree pulse. Now I have several coherent orders. Coherent order can be -2 to +2. And before it is Z, so coherent order is 0. I start with 0. And then after applying the pulse, several coherent orders are there. I have created, let us say, this is not Z, this is already XY. Z means you can create only +1, -1. Since I have created +2, -2, etc., magnetization is here already XY, there is another pulse behind. Don't worry. So now I have created higher quantum coherent orders. I want to select delta P is equal to -3. How do I do that? Now P1 is equal to +2 and P2 is equal to -1. If I take that, now what is my P2 minus P1? P2 minus P1 is equal to -1 minus of 2 is equal to -3. Then I can select delta P equal to -3. So I have to choose this pathway. See, +2 to -1 is the pathway. This coherence pathway, if I choose, I will get delta P equal to -3 only. All other things will be rejected. Not all, I will come to that. Some multiples of that will come back. That I will tell you at the end. But anyway, if some other thing unwanted will go. Let us put it like that. Delta P -1 will be selected. For example, 2, 1, other things will completely get rejected. Now, how do you get the receiver phase now? Delta P is equal to -3. Now we put -3 here. Minus into minus +3 into 5 is equal to 3. So 3, 5. So if I know what is the receiver phase, if my receiver phase is 5, transmitter phase is 5, my receiver phase has to be 3 times 5. That's all I have to do. Very simple. Let me clarify to you very nice in a simple way. See, I am going to choose this pathway. I am going to choose the pathway from +2 to -1. Already this pulse has created, let us say, higher quantum coherent orders like +2, -2, up to +2 to -2, everything is there. When I want to select delta P equal to -3, I can select from +2 to -1. +2 is the initial state, P1, and -1 is the final state, minus 1. So P1 minus P2 minus P1 you have to take. Then it is minus 1 minus of 2 is equal to minus 3. So delta P is equal to minus 3 I have chosen. My receiver phase is minus delta P into 5, which is equal to plus of 3. So now I choose my receiver phase, that is my choice. First scan I will choose it as 0. Second scan I will choose it as 90, then 180 and 270. What should be my receiver phase? It should be 3 times that. 0, 3 times 290 is 270, then 540 and 270 is 810. What do you mean by telling 810 receiver phase? We have only 360 degree. We can go to plus x, minus x, plus 5, minus 5. What do you mean by receiver phase 810? So simply anything above 360, you have to scale it down to within 360. For example, 0 is okay, 270 is okay. 540, subtract 360 from that, it is going to be 180. 810, subtract 360 plus 360, 720 from that, you are going to get 90. So that's all. Simple, it is a equivalent phase. Although it is 3 times, the equivalent phase is 90 only. That's what you have to do. So now I know the pulse phase. I know the receiver phase, which is equivalent of that. 0, 270, 180, 90. 0 is nothing but 360. I have taken as 0 is nothing but this thing. So I did this 3 times of that, and this is the equivalent phase. And the receiver phase goes in the opposite direction now. How it goes opposite direction we will see. Let us say this is the receiver phase here, and also my signal is here. Now when I move this by 3 times, my signal comes here and receiver comes here. It is going like this already. Now I put the signal here. In the third case, what happened? First it was 0, 270, 540, 0, 90, 180, 270. I am changing the pulse phase only by 90 degrees. But this one I am changing in 3 times that one. So what is going to happen? In the third case is like this. In the fourth scan, receiver is here, pulse is also here. So what is going to happen? The receiver will follow the signal. The signal will always add up with the same sign. You are rotating along with this. So the receiver always will add up along with the signal with the same sign. So the pulse phase is incremented by 90 degree. The receiver phase is also incremented to match the pulse phase to ensure the signal is added up. The phase of the pulses and the receiver chooses the required pathway of delta P equal to minus 3. My delta P was minus 3. Now I have chosen the receiver pulse in such a way, transmitter pulse phase in such a way. The receiver phase is also 3 times that, and it goes in such a way that pulse phase and receiver phase goes together. As a consequence, signal gets added up here. Okay. Now what happens to other pathways? Delta P equal to minus 2. Will it come through? Will it go through with the same phase cycle? Let us see. I have the same coherent orders. I want to select minus 2. Minus 2 is, you have to take P1 is equal to plus 1, P2 is equal to minus 1. Delta P is equal to P2 minus P1, which is minus 2. That is correct. Now what is my receiver phase? Minus delta P into 5. Minus delta P is minus of minus 2, it is plus 2 into 5, it is 2, 5. I have to select receiver phase twice of the transmitter phase, pulse phase. My pulse phase, if it is 0, receiver phase is 0, 90 it is 270, 180, 90, 180, 180, 360, 270, 540. Of course, 360 means one full rotation, it is nothing but 0. 540 subtract 360 is 180. So if this is your transmitter pulse phase and the equivalent receiver phase is this 0, 180, 0, 180. Now let us see what is happening. In the first scan, receiver is here, signal is here. In the second case, I think receiver is here. You shifted by one, it is like going like this 0, 180, 0, 180. Okay. So receiver is, from here I moved the receiver here. The signal moved only by 90 degree. Transmitter phase, pulse phase is moved by only 90 degree. And now I move another by 90 degree, but receiver is again moved by 180 degree. And now this again moved by 90 degree, but the receiver again came back here. The receiver I am alternating from 0 180, 0 180. That is, if it is plus x, minus x, plus x, minus x. I am alternately doing that. Whereas pulse phase I am incrementing in steps of 90 degree regularly. Correct? That is what I have done. So what is going to happen now? Signal 1 and 3, look at it. 1 and 3, they are opposite. Receiver is here. In this case, receiver is here, but one signal is here, one signal is opposite. So you get positive absorption, negative absorption, whatever you get, you will get completely nullified, get cancelled out. Take this one, 2 and 4. Again, you get signal, one's positive here, one's negative here, they get cancelled out. So in this situation, for delta p is equal to 2, if it select delta p is equal to 2, the phase cycling for delta p will reject this one. It will not take that one. It is only phase cycling for delta p is different than phase cycling for delta p. So delta p equal to minus 3 phase cycling will not choose this. That it is different. So it rejects this signal. Okay. So that's what is happening. Now what happens to other pathways? Let us say delta p is equal to plus 1. If I see delta p is equal to plus 1, what is going to happen? If I take 0 to plus 1, p1 is equal to 0, p2 is equal to plus 1. So delta p is equal to 1. So pulse phase is exactly opposite. Receiver phase is exactly opposite of the pulse phase. From this equation I calculate, if my pulse phase is 90, receiver phase is minus 90. So do like that, 0, 180, 90, 180, 270 my pulse phase, and receiver phase is this one. Equivalent phase is 0, 270, 180, 90. Now it is identical to delta p equal to minus 3. Something different, right? See, delta p is equal to 2, it rejects. Delta p equal to minus 3, it selects that phase cycling. Whereas now if I want to see the same phase cycling, if I want to select for delta p is equal to 1, it is identical to delta p equal to minus 3. This phase cycling is identical to so that means this phase cycling also will select delta p is equal to 1. So the phase cycling what we choose for delta p equal to minus 3 will also select delta p is equal to 1. Both are identical. Only thing we saw, phase cycling for delta p equal to 2 is different. That is why phase cycling chosen for minus 3 will not accept that, it will reject it. You will not get that through. For to select that delta p equal to 2, you should have a different phase cycling. You cannot have that. So as a consequence, delta p equal to minus 3 will not select that. Whereas delta p equal to minus 3 phase cycling will also select delta p is equal to plus 1. So now you may ask me a question, how many such thing I can select? Can I select several pathways if it is available? For example, let us say for the, I have a situation, I have plus 4 to minus 4, different coherent orders. Delta p equal to minus 4, minus 3, minus 2, everything is there up to plus 4. Now, what are the pathways I can select with the same phase cycling? For the same phase cycling which is called delta p equal to minus 3, I also could select delta p is equal to plus 1. What is the difference between these two? 4. Keep this in mind, I will come back to that. Now, delta p is equal to plus 2 to minus 2 is one pathway. Delta p is plus 2 to minus 1 is one pathway. This is one pathway, this is one pathway, and this is one pathway, this is another pathway, another. Like that several pathways we can see. Now for a 4-step phase cycling we took, remember 0, 90, 180, 270. For the pulse phase 4 steps we took, that is called 4-step phase cycling. Now pathway always repeats at intervals of 4. Remember, which is a 4-step phase cycling. That is why when I took delta p is equal to minus 3, I was able to select delta p is equal to plus 1 also. That is interesting, because in steps of 4, in intervals of 4, it can select all the pathways. Supposing if it were to be plus 5, it would have selected that also, because now this difference is 4. If there was to be minus 7, it would have selected that also. So for a 4-step phase cycling, the pathway repeats the intervals of 4. You get this point, it is very clear. So now delta p is equal to minus 3 is chosen, plus 1 is chosen, and plus 5 is also chosen. It can select if there is a coherent order of that plus 5 or minus 5, whatever it is. If there is a fifth plus 5 coherent order, you are going to get that. Now with this we can form a general rule. What is the general rule? If the phase of the pulse is changed in n steps, that is, here we took 4 steps, we take n steps, then with the increment of 360 by n, in my case 360 by n was 4, so I changed by at the interval of 90 degree. We took a 0, 90, 180, 270 like that. In intervals of 90 we change. So let us say, because 360 is the maximum one cycle you can think of. If I have n step phase cycling at the interval of 360 by n, then the pathway chosen delta p always repeats at delta p plus n times n. Meaning, now I'll take an example. I have taken a 4th step phase cycling. Now n is equal to 4. Okay. Now delta p, if I choose whatever the value I want, if I take delta p is equal to 3, let us say, I'll choose something delta p equal to 3, n is equal to 4. So n times 4, that means n can take value from 0, 1, 2, 3 including minus also. So n times 4, 1 to 4, 1 into 4. So that means 3 plus 4 is 7. And n is equal to 2, 2 into 4, 8, 8 plus 3, 11. Like that, all other pathways which obeys this formula, delta p is equal to delta p plus n into n are also chosen. This is an important point. If you want to select the phase cycling with the n step phase cycling, the n steps correspond to 360 by n. Let us say n is equal to 2. Then here n is equal to 2. Then delta p is equal to n into 2. So you can select n number of things, 2, 4, 8, 6, everything it will select. So then all other pathways which are available, coherent orders if it is present, if the pathways are available, it will select all the pathways which are equal to delta p is equal to delta p plus n into n. They also will be chosen. That is the general rule. What happens when you have more than one pulse? That is the next question. See, we were talking about only single pulse phase cycling. But in multipulse experiments, you can have 2 pulses, 190 pulse followed by another 180 pulse, another 90 pulse like that. Supposing if I want to change the phase cycling of this one, and if I have to change the phase cycling of this one simultaneously, is it possible? Can I have the phase cycling, if implement the phase cycling and choose a particular pathway, if I have this sequence with more than one pulse, 2 pulse sequence, 3 pulse sequence like that, can I have a phase cycling implemented? Can I combine this? If I choose a phase cycling, let us say from here to here, I will put 2 pulses like this. Here to here, I will select one pathway. Then here to here, I may select another pathway. I can select different pathways. Then I need a phase cycling to select this particular pathway from here to here. From here to go here, I have to select another particular pathway. Is it possible to combine two pathways of selection when you have 2 pulses? Yes. The answer is yes, you can do that. It is possible to combine the phases when you have multiple pulses. Take for example, you have 2 pulse sequence 90 and 90, and we have different coherent orders, -2 to +2, different coherent orders are there. Now I want to select this coherent pathway. After the first pulse, 0 to +1, this is the coherent pathway I am going to select. So 0 to +1, so this is +1 pathway, that is fine. 0, this is +1 because P2 minus P1 is +1. Now afterwards, after the second pulse, I want to select this pathway. This pathway is +1 to -1. So P2 minus P1 is -2. That means in a 2 pulse sequence, after the first pulse I want to select delta p is equal to +1 pathway. After the second pulse I want to select delta p equal to -2 pathway. Both I want to do simultaneously because my experiment is like that. I have 2 pulse sequence. Can I do that? Yes. Whatever the pulse phase we chose for delta p is equal to +1 with, let us say I have chosen n equal to 4. When n is equal to 4, for what is it delta p is equal to +1? We know that 360 divided by 4, which is in 4 step phase cycle, 90, 180, 270, 360 we can select for delta p is equal to +1. Accordingly you calculate what is the receiver phase, but we have done that for delta p is equal to +1. Now for delta p is equal to -2, same 4 phase cycling you can have, but now what is the receiver phase now? Same 4 phase cycling, the receiver phase for delta p equal to -2 we calculate, that also we calculated. Now it is easy to combine both. Now for each of the pulse, each phase of the pulse for delta p is equal to +1, 4 different pulses we have to see, ensure that the receiver phase of pulse 2 has to be incremented. For example, let us say this is delta p is equal to +1. I have chosen one phase cycling. For the receiver phase, let us say is 90 here. And now for this, the receiver phase is chosen in such a way, it is let us say 90, 270, 180 or 270, something like that I have chosen. This is my receiver phase. For first pulse, all the 4 should be changed here. It should undergo one cycle. Now increment the second time the phase of this pulse to 180. Again all the 4 should be done. The phase cycling has to go sequentially like this. First, for the first pulse phase of the first pulse, all the 4 receiver phase cycle you have to go through for the second one. Then the second pulse phase of this first pulse, again all the 4 has to undergo, all the 4 receiver phases have to be undergone. Like that, that means you have 4 phase cycling for the 4 pulse phases for the first one and for the 4 for the second one, and that means 4 into 4 you have 16 cycles. Okay, for each time for one receiver phase here 4 receiver phases of this has to be changed. Second receiver phase here all 4 has to be changed. You have to go sequentially like that. Then it is possible to combine both the phase cycling for both the phases. So that is what is going to happen. You can combine that. For example, we have worked out for this is going to be 16 step. I didn't write completely. I have stopped. I got fed up after writing this table. Remember phase of pulse 1, 0, 90, 180, 270 we chose. For delta p is equal to +1, 0, 90, 180 with opposite phase. We saw that. And equivalent phase is this. So first it is 0. This is phase of the pulse should be 0. Start with that. For delta p is equal to +2, it is 0. So equivalent phase is 0. That now the total phase is 0. Okay, it starts with that 0, 270, 180, 90. Second one, make it, you come to 5, 6, 7, 8. It is again now order is going. Now second one is for the 0, 90, 180 is over. 0 equivalent phase is 0, 270. This remains the same, this order. Oh, we don't have to go here. We start this itself first of all. We have to understand this itself. Now for the 90, you have to undergo all the 4 again for 90. Similarly 180, all the 4 you have to undergo. So pulse phase for each of these things, all the 4 you have to undergo. You have to combine in such a way that the entire phase cycling for both of them can go through. So 4 into 4, 16 possible steps you have to choose, and each time what is the total phase you can work out. Total phase combining both pulse 1 and the pulse 2. So if you have more number of pulses, it is a bit complicated to work out. See, this itself we have to go for 16 steps. While working out up to half of that, I got fed up. Imagine if you have more pulses, it is going to be very difficult. But it is possible. People have been doing. You can keep doing that. Okay. So We will work it out for each of these things. First you undergo 4 cycle, keep the receiver phase of the second one 0. Now go through all the 4, keep the receiver phase of the second one as 90. Now go through all the 4, keep it as 180. Again go through all the 4, keep it as 270. Like that. Each time first pulse undergo all the 4 phases, second one sequentially increment 0, 90, 180. Each time for first 4 pulses this should remain constant. Then the second 4 pulses increment this by 90 degree and keep it constant. Like that, this is a procedure you have to follow. It is possible to combine both the receiver phases for both the pulses in multiple sequences. If we took the example of 2 pulse sequence. So this is what I wanted to tell you about the phase cycling. How do you use the coherence selection? How do you get the coherent transfer pathway? For a defined coherent transfer pathway, what you want to choose, you can select it by using a particular receiver phase. The particular receiver phase you obtain by minus delta P into phi. Minus delta P is nothing but P2 minus P1. P2 is the final pathway, P1 is the initial pathway. And depending upon the number of coherent orders we have, choose a particular pathway. Once you choose the particular pathway, find out the receiver phase. And the pulse phase define how many number of pulses phases you want. This is 360 by n. If you want 4 pulse phases, 360 by n is 4. You have 0, 90, 180, 270 like that. So similarly, then you can find out what is the receiver phase depending upon the coherent order you have chosen and the corresponding coherent pathway. If you have 2 pulses, it is possible. You have first for the receiver pulse for the receiver phase, 4 receiver phases are there. Each time you have the receiver phase for the second pulse, and for first 4 receiver phases keep first one constant. Then for the second 4 receiver phases keep the second one second pulse first phase, second pulse phase constant for all the 4 like that. So it is a very complex thing. If you have 4 step phase cycling for first pulse, 4 step phase cycling for the second one, if you have 4 into 4, 16 step phase cycling combined together for 2 pulses. Like that you can work out for any pulse sequences if you know the coherent order and the coherence pathway. All you have to do is to simply calculate the number of cycles you require and what is the receiver phase and which is this coherent pathway you are interested in selecting. That is all we have to do. So with this I will stop for the coherence selection and everything. Next week the same thing we can do by what is called gradients. Tomorrow I am going to discuss about gradients. How we can use gradient to do the selection, select this pathway also. Whatever you did by phase cycling, you can do by gradients. Then what are these gradients? I will introduce that tomorrow. So thank you very much. I will stop it for today.